Yes.
Yes. Yes, Professor Dwivedi is there. Good.
So,
Yeah.
good afternoon, everybody. On behalf of IIT Guwahati, GBS Energy Private Limited, and on my personal behalf, I welcome you all in this webinar. We have got many speakers today, and let me tell you the names of the speakers first, and then we'll start the main program. We'll have an inaugural session, which will be made by Mr. Amitabh Ghosh, Professor S.K. Dwivedi, Mr. N.N. Datta, Mr. Balraj Joshi, there. They will conduct. Mr. Amitabh Ghosh is the director of GBS Energy and ex-senior vice president Texmaco and ex-director of Tikagar. Mr. Dr. Nitish Ranjan Mandal is the chair professor of IIT Guwahati Technology Innovation and Development Foundation and former professor and head of the Department of Department of Ocean Engineering and Naval Architecture of IIT Kharagpur. Professor S.K. Dwivedi is the project director TIDF of IIT Guwahati. Mr. N.N. Datta is CEO TIDF IIT Guwahati, and Mr. Balraj Joshi is ex-CMD of NHPC Limited. After that, we'll have the technical session number 1, where the speakers will be Mr. R.P. Sharma, Mr. Shahadeva Khatua, Mr. Mukulesh Devnath, Mr. J.N. Dubey, Professor Arup Kumar Sharma, and Mr. Saroj Kant Singh. Mr. R.P. Sharma is ex-GM of NHPC. Mr. Shahadeva Khatua is ex-MD Odisha Hydropower Corporation Limited and ex-GM of NHPC. Dr. Mukulesh Devnath is VP Texmaco. Mr. J.N. Dubey is Head of Hydro, JSW Energy. Professor Arup Kumar Sharma is from IIT Guwahati. And Mr. Saroj Kant Singh is Project and Risk Management Expert. After that, we'll have a short break of 15 minutes. And then we'll start with the technical session 2, where the speakers will be Mr. Rishikesh Bharti, Mr. Subroto Das, Mr. Harbans Lal Aurora, Mr. B.L. Gulshan, and Mr. R.N. Ghosh. Dr. Rishikesh Bharti is from IIT Guwahati. Mr. Tapan Kumar Das is from Indian Register of Shipping. Mr. Subroto Das is hydropower expert and consultant. Mr. Harbans Lal Aurora is hydropower and dam safety expert. Mr. B.L. Gulshan is hydropower consultant. And Mr. R.N. Ghosh is also a hydropower consultant. Then the interactive and valedictory session will be done by Dr. Nitish Ranjan Mandal, Mr. Amitabh Ghosh, and Mr. Niranjan Saha. The whole program will be anchored by Mr. Arnab Banerjee, myself, and Mr. Saroj Kant Singh. With this, I now request Dr. N.R. Mandal to start his inaugural speech. Over to you, Dr. Mandal.
Okay, thank you very much, Mr. Banerjee. Uh, so that is Mr. Banerjee has already told you. I'll give you uh, the essential background. I mean, what has led us to organize this workshop. So anyway, at the outset, let me very good afternoon, and formally, I welcome you once again to participate in this today's workshop. The background of the current disaster that took place in Sikkim and West Bengal, the Teesta Riverine belt, immense damage to a number of hydroelectric projects. We have thought of deliberating on various issues concerning safety of these projects. In fact, based on our first-hand experience on some of these projects, discussing amongst ourselves as to what we can do to safety in this hydroelectric sector. Hydel power station, some failure took place. Have first-hand experience. We have visited those places in Peru. So before we could, so we had been talking about this for almost last 1 year or even more. So to initiate any concrete move, the Sikkim disaster came as a shock. Safety, but anyway, we could move about, but we stayed. So, in fact, this has triggered the necessity of deliberating on these issues, and the result is this workshop. I am sure our efforts in this direction will go a long way, not ending with the conduct of the workshop. That is our focus. That it's not just do the workshop and say good. No, it should have a long fallout for this. I would like to recall what our Prime Minister said of Sikkim disaster. Quote, the opportunity to learn from a disaster must not be wasted. It's very nicely said. The opportunity to learn from a disaster must not be wasted. Unquote. Anyway, so in this background, this workshop is being done, and here I would like to highlight some of the aspects on which further deliberations can be done. I think it's what I feel is that training of manpower on issues of safety aspects of hydropower. It's why? Because as we see that there are not many people properly in in this area, in this discipline. And all these hydropower projects are in a very remote locations. So that is one of the hindrance why it is difficult to get good people uh, working for this hydropower. That is one aspect. Second is, as my personal experience and also Avitavoda, Mr. Ghosh's experience, that there is some, as if some lack of proper check, proper monitoring, proper inspection in these projects when they are implemented. If I draw a parallel with shipbuilding industry, because I happen to be from that discipline, stringent monitoring and very meticulous inspection is carried out right from the beginning, the design stage to finally test and trial stage to the handing over of the ship. There it is done. There are so-called classification societies, registered bodies are there, like ours is Indian Register of Shipping. We have a from Mr. Dhor, Tapan Dhor is there, who will be sharing his expertise with us today. So, like in shipbuilding industry, we have these classification societies who care of the design checking, then material inspection, construction inspection, and carrying out tests and trials. Everything in their presence, it is done. So there is a thorough check because we cannot afford to have a disaster once the ship is built and launched and delivered. If we have any failure taking place there. Unfortunately, if you look into the hydropower sector, if you really go into the little bit, check the histories of various, what I can say is the coming hydropower installation which was in Arunachal, so-called charging of the penstock started. Hardly 40 charging has been done, and failure occurred in the penstock. And occurring in penstock means huge flooding take place in the. That resulted in a long delay of the installation of the project. Implement. So that is very shocking. Shocking in the sense, before I could complete the project, before the project is handed over, already failure is taking place. What actually my experience goes is we have that is it gave me an impression of lack of proper inspection and proper monitoring in the construction as well as design in the material selection. Various issues are there. Next point which comes to my mind is the risk. Well, risk factor is there in all industry, be it a aircraft industry, be it a shipbuilding industry, motor car, everything. Meanwhile, we have stringent rules, norms, etc. To look into this. So, in this hydropower sector also, to mitigate these risks which are there in this, as we see in way of failures taking place, the all-round safety rules, stringent norms and stipulations have to be worked out and enforced. Then only we can say, like the disaster in Sikkim, what has taken place. There are in the media you have seen. There are many things are being talked about, even to the extent of people are primarily putting the entire blame on the that flooding which took place, drop or some short form they're using. That even people are saying that some ammunition depot got washed away, so the ammunitions came and they exploded, and thereby the dam got damaged. Well, many theories can be put, but the fact remains that there was a lack of proper kind of monitoring, inspection, etc. Things were not there. So had those things been in place, proper place, probably could have had avoided the damage to the dam, to the hydropower. Flooding takes place, okay, that can be that because of drought and all that could have been avoided. It's a colossal wastage of national infrastructure as well as uh, financial waste, everything. So with this I thought, I thought to tell you at the outset to set the ball rolling for today's workshop. So thank you very much. Thank you very much. And I will now hand over to Mr. Amita Ghosh.
Yeah, our next speaker, Mr. Ghosh, please take over.
Yes.
Thank you, Arnav. Am I audible?
Yes, you are totally audible.
Okay. Good afternoon, everybody. On behalf of IIT Guwahati, TIH, TIDF, and industry partner GBS Energy Private Limited, we welcome you all in today's workshop. The subject is Natural Calamity and Disaster in Sikkim and West Bengal on Teesta Riverine Belt, a relook at hydroelectric sector with challenges, opportunities, and roadmap towards mission hydro safety. In view of this apostate disastrous situation and based on our background of IIT and long exposure in concerned industry, Dr. Mondal and myself thought that IIT and industry experts can work together for suitable long-term solutions towards mission hydro safety. I'm using this word mission hydro safety because this one word is missing in the hydro sector. We should make a project very safe and should not create unsafe situations to others in society on downstream side, which has happened recently in Sikkim and West Bengal. And moreover, furthermore, the experts are of the opinion that apart from natural calamities, human errors have happened in Sikkim disaster. So this is, they are saying that we may call GLOF and cloudburst natural, but the disaster that has happened after the breaking of the dam is entirely human-made. So government has formed a high-level technical committee. They will have their findings and all concerned will do some work for some time. Because I had the experience of working in that terrain for a long period and many other hydro projects. And from time to time, if something happened, this is the normal procedure. But after some time, it again go back to the original position. The safety factor is totally missing. Dr. Mondal says shipping safety, mining safety, fire safety. There is no hydro safety. So that's the thing which we thought that we should try to ensure. But how? We must, the best of the theory and practice, that is IIT and acclaimed industry experts should put their efforts together to make this happen. And so, accordingly, I have made some points on that. We say way forward, what we should do, forward. We say that mission hydro safety is essential for various reasons. First of all, we are saying hydro projects are essential. People are saying that we should not do any hydro projects. Like recently I said, GTA has taken a decision that no further hydro projects in Teesta belt. And similarly, somebody is telling that no further hydro projects in Himalayan terrain. I mean, these are the things we should and we should face and address. First of all, hydro projects are very much essential for various reasons. This is the sustainable, everybody knows, sustainable, renewable, green energy towards net zero. And then focus on pump storage hydropower for storage of energy with hybrid application. Then it gives grid stability and balancing. And also, India is having a huge untapped hydropower potential. Today the total capacity is 52 gigawatt installed capacity, and estimated potential capacity is 145 gigawatt. So around 75% potential capacity is untapped. Against total power generation capacity of 416 gigawatt, hydropower generation capacity is only 12%. And finally, hydropower electric projects should be safe and should not get, this is the thing I have told earlier. Another point is very important, is that from the geopolitical consideration, particularly in the Northeast, to combat the political situation, we need to have big size hydro projects, no doubt about it. But how we mitigate the risk, that is the concern we should see. So in order to mitigate concern, we should have stringent, comprehensive, all-round safety rules, norms and stipulations, and these have to be enforced in all stages of work. Now, what are the stages of work? First is, the Stage 1, conceptualization, identification, feasibility, and upfront engineering. That time itself, we can choose a hydro project which is better, safe. Stage 2 is the execution, engineering, procurement, manufacturing, quality assurance, construction, erection, commissioning. And stage 3 is what has happened, operation and maintenance. Strict and stringent safety norms are to be implemented and ensured through safety quality audits, which are required to be carried out at all stages of work on a regular basis. So these are the things. Now, which Dr. Mondal said just now, in hydroelectric sector, more number of trained manpower is required to be developed to carry out safety audit and ensure safety norms on a sustained basis to achieve success towards mission hydro safety. These are the 2 points. And other points which I want to say that we must learn, which Dr. Dr. Mondal said, this is again quoting our Honorable Prime Minister, the opportunity to learn from disaster must not be wasted. We must learn and bring this learning to apprise future projects critically and ensure safety. Those who do not learn history are doomed to repeat it. So we have to create confidence amongst people and society about hydroelectric power projects, about its safety and benefits. With this, I would like to thank you very much. Or no?
Thank you, Mr. Ghosh. Our next speaker in the inaugural session is Professor S.K. Dwivedi, who is Project Director TIDF IIT Guwahati. Professor Dwivedi, please take over. Professor Dwivedi? Yeah. Professor Dwivedi, you are muted. Can you unmute yourself and start? Professor Dwivedi, can you hear me? Professor Dwivedi is in the meeting, but
I think
he is unable to connect.
somehow he's unable to connect. I think we can go over to Mr. Dotto.
Yeah, so we are, in that case, we are going to Mr. N.N. Datta, CEO TIH TIDF IIT Guwahati. Mr. Datta, can you start your speech?
Great opportunity to interact with the finest brains in the area of hydroelectric energy in our country, because what Mr. Ghosh was talking about it, or Mr. Dr. Mundal was pointing it out. Yes, we need desperately green energy, because whatever we agreed in the Geneva Convention, though the time is 2070 for making a carbon neutral, but still we have got miles to go. And I think this is one of the big steps where we can take such kind of this thing. But at the same time, we need to be very cautious about the construction and what was being echoed by both Dr. Mandal and Ghosh, the safety aspect of it for the dams, because we haven't learned what we have seen in 2021 in the Chamoli disaster, because that was a disaster. And whether it is GLF or it is a cloud burst, this is a natural, it is going to happen in the Himalayan belt. Now, the moment we're talking about a catchment area and the kind of construction we need, and the kind of the velocity of the water at that speed, I think basically what has happened in Chungthang now in the Sikkim, it is basically a replica of the same, that it just couldn't control the massive outburst of the GLF. Now these are, I think, I don't know, I'm not an expert, so whether there are these are the structural issues, these are the issues in terms of engineering defects, or the issue is not in terms of anticipating, understanding the natural aspects. So I think these are the points we need to really look at it. Can we have some kind of more robust structural designing for such kind of projects, or like what you were now talking about it, can we completely stop in terms of doing it in Himalayas belt, right? So the question is whether we are talking about run of the river plants, or we are talking about creating a artificial dam. We need to be very cautious about the location and the geographical, the plus minus we have in that particular location. I think this is left to the those talents that we have here to think about it, so that we can avoid such kind of disaster going forward. I think that's from my side, sir.
Thank you. Thank you, Mr. Datta. Professor Trivedi is present. Can you join now? Professor Trivedi, can you hear us? He is still not there.
Is it
Yes, sir,
there?
yes, sir, I'm able to hear you.
Yeah.
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 So,
Okay, so on
I
behalf
will
of IIT, TIDF,
Please
so I
start your.
congratulate. Am I audible?
Yeah, you
Yes,
are
yes,
audible.
yes.
Please
Last
go
time
ahead.
we did not get you. You could not connect us, I think.
No problem. So now I have connected and I am
Yes.
listening to both
Yeah.
Professor Mandal and you. So thank you very much. So I now I first congratulate on behalf of IIT, TIDF. So I congratulate Professor Mandal and Mr. Amitabh for conducting this workshop. So this will be very helpful actually, and IIT, TIDF will extend all helps to conduct similar courses, and also we can financially help. So if someone come up with some startup which will monitor this type of activities, so I request Professor Mandal to coordinate such activities. And with this, I conclude here. So thank you very much for conducting this certain course. Okay, thank you very much.
Our next speaker is Mr. Balraj Joshi. I think he is not yet joined the forum. So, in that case, can we go ahead for technical session 1? Mr. Ghosh, please suggest.
Yes.
So, let's
Yes,
go
I
to.
think
We can go to Mr. Khatwa. Mr. Khatwa.
So,
Khatwa,
Yeah,
sir.
good afternoon, sir. It is a nice
Yeah.
discussion going on. I was listening to it.
So, in technical session 1, Mr. Khatwa, please start your presentation. Yeah.
Mr. Khatwa
Yeah.
was ex
Yeah.
NHPC and ex Managing Director, Odisha Hydropower Corporation Limited, and good friend of mine. Khatwa, sir, please.
Mr. Khatwa,
Good
please.
afternoon, all of you. Very learned people and discussing about this, how to avoid this type of disasters in future. Actually, this will be eye-opening for all of us. We can get some hints from many speakers how this can be avoided in future. I have worked in Sikkim in construction of two projects from 90 onwards till 2007, and Teesta 5, which had also been badly damaged because of this cloudburst and this, you can say, glock. And I was also in that. Our Amitabh Ghosh was also there, and I was also there on behalf of NHPC. And see, while we design this dam or any hydraulic project, we take care of all the things that may come in next 100 years. And this our Teesta 5, especially I'm talking about Teesta 5, I'll also come about the Teesta 3 also. Teesta 5 is around 70-75 kilometers from South Luans Lake, which burst on 3rd of October 2023. when a lake, this lake, South Long Lake, as per the ISRO data, the volume of lake will be around 40 million meter cube. Its depth is 79 meters. It is around 1.6 square kilometers, and total volume of water that it carries is around 40 million meter cube. That is also debatable, but it is around 40 million meter cube. As per the ISRO data, aftermath of this disaster, it is felt that around 20 million meter cube of water has flowed on that day from that lake. Lake is not completely dry. Some volume of water is still there. It is about 20 million meter cube of water has already come from there on that day in few hours. You can say in few hours. Main thing is, for any dam, we should have that early warning system. If any disaster is taking place or high volume of water is coming from the river, which may affect your dam operation or the project operation, that early warning and taking action immediately on that. What action we should envisage, what action should be taken during operation of this project. See, I was just calculating this 20 million meter cube water, when it comes from, that is the Teesta 3, the discharge capacity of gates in Teesta 3 is around 7,000 cubic meters per second, cumex. That is 7,000 cumex of water can come from those gates. You see, it is around 40-45 kilometers away. That Luan's Lake is 40-45 kilometers away. It was sufficient warning was given about 2 years back in 95, again 2008, again 2015, again 2019. Different agencies have given warning to Sikkim government and other agencies. The Luhan's Lake, Lunak Lake, is really a very danger for the Sikkim. Anytime it can burst. That block may happen anytime. And they tried to, ISRO also tried to put some early warning system that didn't work. On the night of 3rd October, it was still raining heavily on those areas. And I'm talking about Teesta 3, as information has been received, the gates were not properly opened. As they learned about this about maybe few hours or 45 minutes or 1 hour before this disaster took place, when this water started coming, one maybe army personnel or some BRO personnel, they could see it in the night, and he informed immediately. But the gates could not be opened in Teesta 3. The water reaching there, it takes about 1 hour 20 minutes from Luan's Lake, Lunak Lake to this place, about 1 hour 20 minutes. By that time, any dam operator, I think Amita Ghosh can also say, those gates could have been opened. Somehow, whatever information the dam operator got it, they could not open the gates properly or fully. And that was a rock-filled dam. I cannot say that is foolproof, properly designed. And it has also worked for 5 years. But any overturn of a rock-filled dam or earth-filled dam, it is disastrous. And when the water came out, 20 million cubic of water coming, and this reservoir is almost completely full that time. And it overtopped the dam and making a bridge. This 20 million cubic meter, again, this capacity of Teesta 3 reservoir is around 5.05 million cubic meter. It means total it became around 25 million cubic meter water from Chungtham. And it might have taken around 30 minutes, 40 minutes to flow. And it reached Teesta 3, Teesta 5. There also similar thing happened. The gates were partially opened and reservoir was more or less 90% full. The district administration and some other agencies of Teesta 3, they gave message to the Teesta 5, but somehow the dam operators at Teesta 5, they tried but could not open the gates. Teesta 5 has 5 gates, and the design capacity of Teesta 5 radial gates out of 5, the capacity 10,400 cumecs for 4 gates. Thinking that it is designed as if one gate is under breakdown, with 4 gates that could have carried discharge 10,400 cumecs. It meant if they would have immediately tried to open all the gates and discharge the whole of the reservoir, their reservoir, before the water reaching there, before the water of Teesta 3 and Lonak Lake reaching Teesta 5 dam, they were completely emptied the reservoir. With all the 4 gates to completely empty the reservoir, it would have taken 9 minutes. If all the 4 gates are open, for 5 million cubic meter to go through the gates, it would take only 9 minutes. And they got the message about one hour or more before that. Had that been the case, the 25 million cubic meter coming from Teesta 3 would have come in a time, because on that period from Teesta Chongtham to our this Dikchu is about 20-25 kilometers. That river length, 25 or 30 kilometers river length, that would have taken around 30-35 minutes. And the flood intensity below Teesta 5 dam would have been reduced, because this 5 million cubic meter water would have gone earlier, and the whatever water is coming, that would have gone around 10,400 cumecs or so, gradually that would have passed through the river. Okay, what happened? Because the gates were not fully open, when the 25 million cubic meter coming from the Teesta 3 up to Teesta 5 dam, the gates got breached. All the 5 gates got breached, and might have, and this river, the dam also overtopped. It means the water volume passing through Teesta dam during those particular time might have been around 15,000 cumecs or more. That is huge flood, and that dam made a lot of damages. Similar thing happened. We have a project, NHP has projects at TLDP 3 around Rambi and Kalijora. They got the message, and immediately they emptied the reservoir. TLDP 3 reservoir was emptied, they got enough time. TLDP 4 reservoir got emptied, they got enough time. It is not the enough time they got, they acted quickly. Once they got the message, they acted quickly. As a result, when the water came up to Teesta TLDP 3, because of long distance, intensity had already reduced slightly, but the reservoir was already empty. What happened? Some water was there. Because of that empty reservoir, the total intensity of flood was reduced there. Similar is the case of Teesta 4. In this case, I want to tell everybody how our early warning system should work, and the decision making of the system should be decentralized, so that the people working in the dam, they should be trained. If they get a warning like this, what they should do, how the reservoir operation should be done, so that this flood does not affect downstream to that particular project. If the trained people are there again it is happening in night, because this happened night, the decision making process is also delayed. For that purpose, as a disaster management issue, I will suggest that the people working in night shift, they should be properly empowered. They should be trained to take decisions how to operate those reservoirs. As you saw, 20 million cubic meter water coming from Lonak Lake would have been absorbed even in Teesta 3. That is a 5 million capacity, 5 million cubic meter capacity. And when water 20 million is coming, that is distributed in certain time. And I tell you, for 5 million cubic meter of water to discharge through the radial gates of whatever gates there in Teesta 3, it would have taken only 12 minutes. In 12 minutes, they could have completely emptied their reservoir. Then whatever water comes, that would have gone through that might not have overtopped. It might not have overtopped that, and the dam could have been saved also. That is to be calculated exactly how much water has come exactly. As a construction engineer, as well as I was in operation in 5 years in 2 projects of NHPC, this Teesta 3 for 3 years and 2 years in Rangit project. This disaster effect could have been reduced substantially had the operation of these projects could have been done properly in a scientific and professional manner. And the early warning system in all the lakes, as you know, we are going through the papers and other things, that lot many lakes are there which can be affected, damaged in any type of block. Will again come. In Sikkim, they have identified 7 or 10 similar big lakes which may damage any time, that may breach any time, and similar flood may come. That's why on those things, suitable early warning system should be there, and that should be how the people, it will go to the people staying on the riverside. I have seen this, Ghosag also seen, people, most of these small towns in Sikkim, people stay just on the riverside. Any flood coming like Dikchu Bazar, Singtam Bazar, Rangpo Bazar, very badly affected because of this flood. If they get early warning, get the message, at least their life can be saved. That's a very scientific way of operating the projects is also similarly necessary along with this early warning system. Thank you.
Thank you, Mr. Khatua.
Thank you.
Excellent presentation and very, very informative. It's indeed very informative. So I now next invite Mr. Saroj Kant Singh. Saroj, are you ready?
Yes, I'm ready.
So you start your presentation, please.
Right. Is this presentation visible?
To make it full screen.
Okay. Your screen has come, but not the presentation.
Yeah, the
Okay.
screen has come. Make it full screen, then it will be visible. We can see it, but with our photos also.
Okay. Now it is not visible, huh?
Now it's not
No.
visible. You have not shared now.
Okay, let me reshare.
You reshare? Yeah. Now we make it full screen. That's all. It's fantastic. Start.
Okay.
Yeah.
Okay, sir. So thank you for giving me this opportunity. I'll be speaking on disaster risk management. So here, most of the experienced people know that risk is something that is related to the future. Anything that is happening or has happened is not a risk, but it's an issue. That's how we call this in projects usually. Now, when it comes to large scale risks which high impact, these transform into crisis and then disaster. So crisis is something where the risk occurrence probability has become very high, but it has not occurred, or it's in the process of occurring, and disaster is the aftermath. So with this in mind, I'd like to share what is called the diamond model of science research inquiry, where we usually sense a problem, and we use this model without sometimes knowing that we are using it. So we sense the problem and then we form a conceptual model. So this is the first stage, as you can say, in the scientific inquiry. From the conceptual model, we make a scientific model. So in the scientific model stage, we give some symbols and we call it the syntactic phase. And then we go to the solution in the scientific model, which is usually statistical. And we know that there is a type 1 and type 2 error. And this is the empirical phase. What we usually don't know is there is a type 3 error, which occurs from problem sensing to conceptual model, where we are solving the wrong problem. And this is very much there in a crisis. And after we have found the solution in the scientific phase, we actually go to the pragmatic phase, where we implement the solution. And in this phase, we have political errors. And this is the pragmatic or practical phase. So this is a diamond model of research inquiry, scientifically how we solve a problem. And if we follow these steps, likely we will arrive at a good solution and then implement it. However, it's not as linear and cyclic as it appears. Sometimes from problem solving, we also find a solution. So this is not cyclic, but it can go from any stage to the other. Now, Mitrov uses this diamond model to solve a crisis. Now, let us see how this happens. First, we have a threat sensing. So let's take the Teesta example. We sense that a flood might come. And so we take some remedial, or you can say proactive actions. So if you look at the first phase, we call it the before phase. So we make a crisis management audit and determine the scope of anticipatory steps we can take. The second phase is a planning phase. So we plan the crisis, we conduct trainings in projects. These are usually safety trainings, and we develop systems so that we can handle the crisis. So from the crisis assessment, we come to the crisis capabilities. And from the crisis capabilities, we try to contain the damage. And this is what we call the during phase. What happens, we actually enter the crisis. So if you see, from threat sensing to crisis capability is actually risk management, or we can call it crisis management. And the crisis enactment is actually when the crisis is happening, or the risk has occurred or is occurring, but not in its full fledged impact. And then after the damage is contained, we take future learnings from here and redesign the system. Now from here, we will briefly talk on how the present technologies can be used. And this is a research paper by O.R.S. Rao. He was the Vice Chancellor of IIT University. And he mentions that there are the stakeholders and the technology. And technology can be used to contain the disaster. Now, if we come back to the diamond model, we'll see that when we do the threat sensing, we are actually feeling that the problem is solvable and it is a structured problem. But usually these are not structured. So what Mitrov calls these as ill-structured messes. So it's a mess. We feel that it is structured and we are trying to solve it. And then it goes like a viral or a spiral, and it gets messy and messy. So this is how the crisis happened. Why we are saying this? Because we will try to understand how technology can resolve, make it more structured. So if we look at the Teesta crisis that happened, we are all using Google Maps, and a lot of research is also happening and has been done even on the Teesta Basin. And this is an image from the Teesta Basin. And this is a research done earlier. So just like Google Maps, where you see, if you go from, let's say, Newtown to Guwahati, you see there is a jam-packed road and you avoid it. Similarly, from satellite imagery, you can easily get the water levels. And as Mr. Khatwa was saying, that the second stage of the damage could have been avoided if an early warning system was there, and this satellite imagery could trigger the early warning system. So when we use these advanced technology which can be used from the data of the satellite imagery, we can contain the damage. And if a structured problem is to be solved, we first have to make sense out of the ill-structured messes. Thank you very much. And with this, I think we can go to the next speaker.
Thank you. It was an excellent presentation from industry perspective. And before we go to Professor Arup Kumar Sharma, who is our next speaker, may I ask if anybody has got any question to Saroj or Mr. Khatua? If anybody has got any question, please. So, okay, there is no question. So, our next speaker is Professor Arup Kumar Sharma from IIT Guwahati. Over to you, Mr. Sharma.
Yeah, good afternoon. Can you hear me?
Yeah, we can hear you and it's very loud and clear. So,
Okay.
Carry on.
So I would like to share a presentation. Let me just see. If my presentation is visible now?
No, sir, not yet.
Now, is it visible?
Now it should be coming,
Yeah,
yes.
it's coming.
Not yet, not yet.
It is coming, but small or something like that?
No, it's not
No,
yet. Same thing happened. What happened in the case of Saroj? We are seeing our picture along
Sir,
with.
I think there is one option, entire screen. You have
Entire
to go to
screen.
that entire screen.
Okay, then let me share it again, because it is showing us presentation, but then let me share it again. I selected entire thing, I think. Entire screen, okay. If my presentation is visible now?
Yeah. Now,
yes.
Just make it full screen now. Just
Okay.
make it full screen, then it will be okay. Yes,
Okay.
perfect. Perfect.
Okay.
You can carry on.
Okay, very good afternoon. It is nice to meet all of you. I think it's a very important topic, particularly in the northeastern part of India. Many dams are also coming up, and dams are there. And so far, this Sikkim disaster is concerned, it has just alarmed a bell. And some other disaster are also there here in this part in Subansiri a few days back. Anyway, that what I would like to focus on, that is any climatic disaster, how we can mitigate those through flood forecasting and dynamic operation of the reservoir primarily. So as we all know, that hydropower is as such considered as the clean and renewable energy source with lower greenhouse gas emissions. So from that point, actually climate change, when we consider this is a advantageous, fact. But there can be several negative impact on the riparian ecosystems due to presence of them, as we know, that as we see that this river is flowing, suppose normally in the scenario as I am showing, but when we give the dam, then particularly in case of interbasin water transfer, hydel project, this kind of thing, the flow depletion occurs in the downstream, so the fish and other aquatic species also suffer. In the lean period particularly, it happens. And then when the high precipitation occur in the monsoon period, then due to that, heavy flood hydrograph come, and that when we release through the dam, then it causes severe flooding at the downstream. And if somehow we cannot release that water, then again it will lead to overtopping of the dam, and that leads to again bigger damages like that of the, Sikkim cases. So, one point is that sudden release that caused disaster. Another is that if we do not do that release, then there is a failure. So how we can do the release in the best way, that is another important aspect. Now, in the light of this climate change, nowadays what is happening, that precipitation pattern as well as inflow to the reservoir, these are changing. So we conducted a study in Sikkim also earlier, and recently we have conducted on the entire Brahmaputra, and that is where the Sikkim is located. This detail can be seen in the paper that I have just put here at the bottom. But rainfall, again, where it will increase, how much it will increase, in which time period it will increase, that is again another issue. But then on an average, if we see that pre-monsoon, it is showing that 2 to 5% down, low rainfall. But in monsoon, it goes to 11 to 20% up here. And in the post-monsoon, of course, we are not finding very significant change. And in winter, it is increasing, but not very significant. Similarly, temperature is also changing with different, when we consider different scenarios. So this is there. Now, this precipitation and temperature combined, when we talk about the flow, then I'm just giving another example of the Brahmaputra basin. Of course, in one of the measuring section, there in monsoon, we found that from 2020 to 2040, 1.5% down the precipitation, the stream flow. And in 2040 to 2070, it is insignificant. But 2070 to 2100, when we go, then your monsoon flow is increasing by 13.06%. That means significant increase. Of course, there are a lot of uncertainties involved into all this point. And winter, it is going down. So when in winter it is going down, that is another kind of disaster, the low flow situation. That is also, we are expecting soon. So we should be very careful, and very carefully we need to operate. This is one issue, is that change of precipitation as well as flow pattern due to climate change. Then another point I would like to highlight, that land use change, because the total inflow to the reservoir is changing, not only because of the precipitation pattern, but also because of the land use pattern. Now, when a dam come or a reservoir come, a township come, and gradually that area also start developing. Otherwise also, gradually we are developing at a faster rate. So all these developments lead to change in the, upstream catchment, and that leads to, more and more inflow. Just as an example, I'm showing one of the hilly area here in the northeastern part, that you see the green area are the, hilly area, and the whites are the plain area, and the red are the developed area or the habitat area. And that was the scenario in 1972. Now, when we come to 2000, then it comes like this. That means all hills are getting, encroached, we'd like to say, because this is not a permanent, or allowable habitation kind of thing, most of the things are. And then when we come to 2020, then it will be more of rate in all the patches. And that actually has led to, if you see, we did this study long back, and then it increases the inflow, or it increases the flow rate to a very high value, 37% increase in the flow value. But more than that, the sediment, because when you remove the vegetation, we go for urbanization, sediment load increases to even far higher value, that is 97% high. You cannot imagine that 20,000 which is there, and that goes to 2,90,000 if you remove all the vegetation. So that way, this is why I'm emphasizing this point. It is the type or characteristic of the soil and the characteristic of the rainfall. The rainfall erosivity factor is very high, and soil are very erodible. So that's why we need to be very much careful in handling those situations. So we are in a two problem facing the things, but otherwise also people at the downstream, that is another third aspect, that people located at the downstream are always saying that because of the sudden release from the dam, flood is happening and that disaster is happening. They are not saying that flood is happening, but they are saying that it is becoming disastrous. And then when we analyze the things, why it is becoming a disaster, the reason is that this is, I mean, this blue line is showing basically the inflow hydrograph to the reservoir, and the other yellow line or the green line or the red lines are showing the release at the downstream and at a flood prone area at the downstream, how the hydrograph is changing. Now, these are routed with different inflow storage. When your different storage of the reservoir. If the storage is full, at that time, if the flight hydrograph comes, then you are releasing more water. If the storage is slightly empty or you have a flood cushion, then you can release less. But whatever it is, very interesting finding we got here, that even with the small one, when we do the small kind of hydrograph, you see 3850 was the, I mean, flood peak of inflow hydrograph, and just at the downstream, it is not increasing. It is 3824. And your natural flow is 3850, of course, and this is not increasing that much. Then when we go for the bigger, it is also 5100, the flood peak of the inflow hydrograph, but then flood peak of the reservoir outflow at hydrograph is 4864. And then when we come downstream further to the flood prone area, then it is further going down, 4091. And that brings the another interesting finding, that when in a natural situation, when the dam is not there, the peak is 4829, and with dam it is 4091. So it is as such not increasing. Even in the first one also, if we see the 3605 without the dam, when it is coming, it is 3662. And so it is, peak is not increasing. But why then it is becoming disaster? It is because of the suddenness. Flow characteristic is changing a lot. I mean, the Brian, they gave the all disaster of the globe, they ranked. And then in that, actually, your flash flood and all those things were coming quite lower. But the suddenness factor, in case of flood disaster due to this kind of dam release or dam disaster, is very high. And when we analyze all those things in detail, then we could find that in case of dam, when regional flood occur, in the flood time, in the monsoon time only, we are releasing the water to downstream. So it's a combination of basically regional flood as well as the flash flood. So when we combine these two, the suddenness factor increase a lot, and this dam-induced flood comes to a very high level of 2 ranking. That is the top 2 ranking it comes. And this, for more details, if anyone is interested, can go through this particular paper that I have listed here. There we will be getting, I mean, all details how this analysis is done. Now, these are the issues, and then question is that how to solve these issues. And then you can see we are working on a particular aspect that already, I mean, many of the speaker like Professor Khatua, Mr. Khatua, as well as earlier speakers have told that early warning, yes, that is extremely important. And for that, better forecasting is necessary. Otherwise, without a good forecasting, if we release beforehand, that's not solving our problem, because power production will also go down, as well as we may not be mitigating the flood. So this figure, actually, you can see that how our basically power efficiency, this red line on the top, it is the power efficiency. We are not compromising with the power efficiency. And if we have forecast horizon, suppose 7 hours or 10 hours or 12 hours, but beyond that also, if we forecast, that is not helping, that efficiency is coming down. Flood control efficiency is coming down, or downstream release efficiency is coming down. So up to certain forecast level or advanced forecasting, or we can call it as a forecast horizon, then what is that? This red shadow or this red shadow is showing that when we can release in advance or when we are releasing in advance. This is for 2 practical dam site we have done this. And then this is what is the inflow hydrograph, that dotted line. And then if we make advanced release, we can bring it down to the green line. And then when we are getting the downstream, because downstream also there will be tributary joining, but considering all those tributary joining, then we are getting the red one, which is the downstream flood. Now, if we do not do this, for that, what is that? A couple model is required, that when you are releasing at downstream, what is happening, and that feedback will come to the reservoir, and that way you are controlling your release or you are making an advanced release. So based on advanced forecasting, you can generate the scenario at the downstream by using hydrodynamic model, and based on what is the scenario at downstream or potential scenario at downstream, that feedback can come to the reservoir operation, and accordingly the advanced release can be made. So you can see the danger levels is here on the right hand side bottom figure. And then with this kind of operation, we are limiting ourselves to the downstream bottom level. Otherwise, the flow goes high and cross it. As I told that earlier, peak is actually not increasing, but then not increasing much. But in this, we are bringing the peak down further and bringing lower to the, the danger level. So this kind of, models are available. And next one, that to control the sediment yield and water yield by ecological management practice. We'll have to go for ecological management practice in the upstream catchment. And how we can do this, that even in a very habitat area we tried and a pilot project was implemented there. Initially we conducted a study, and then we suggested that this kind of different combination of different measures, starting from rainwater harvesting and vegetative measures and other measures, structural measures. And then with all these measures, we even awareness is important. We did a lot of work on awareness generation also. Then these kind of booklets were published, that urban carrying capacity, how much actually we can, carry the development in the hill, how much population can come there, rainwater harvesting system, what kind of effort we can make in that direction, what kind of drainage system we need to develop. All these booklets were circulated to the people and also to the administrator. And then this kind of awareness campaigning were carried out. After that, government agreed to implement that kind of things. People agreed to implement. They stopped hill cutting themselves, putting this kind of, here it is written that 10,000 will be the fine if someone cut the hill. And these are the fine for the people whose income is only 5,000 kind of things. So this is very important, that they have themselves has come up and have taken up this kind of state. And then we implemented it fully. And after, I'm not showing the in-between things, after complete implementation, it has become a green watershed. And the water coming out from this is totally reduced. Sediment coming is nil. However, some other, quality is another aspect, because you can see the green here is also coming up. So that need to be controlled by environmental point of view. So that can be controlled. So, but then with all these things, what we can do, that we can control sediment yield and water yield from the catchment. We can operate the dam in a better way with all the technology available, and we can reduce this kind of disaster, and operation should be more, prudent, by the more fast, rather, I'd like to say. And regular maintenance is required. Sometimes it may happen that sluice gate is not opening or something is going wrong. So I'd like to conclude with this very specific point, that more flexible design is needed considering flow scenario under climate change. So more flexible design means, what I mean by that, number of gate that we are operating, and then operation also should be more flexible, and it should be integrated. Sometimes when we release some amount, suppose the dam is releasing some amount, dam alone cannot alone send a warning, because what is the flood situation at the downstream, or what is the flow situation at the downstream, that is not clear. So a integrated system is necessary, where we'll get through sensor the information of the flow at downstream. We are getting the information about how much we are releasing from the dam, and then the model can be run. We have developed a model of that kind. We are calling it as the Brahma DRFF, and that will be implemented in a particular project here. And with that, we can be very well advanced. We can say that this much flow is coming. So there should be more, clear notification. Then potential land use change at upstream need to be considered with utmost care. And dynamic operation of the reservoir is necessary, as uncertainty is an integral part of the hydrology. So, we should be ready to operate. So that means how we open the gate, that those systems also should be modernized, so that simply by switch, or simply by operating it in an easier way, we can open it to the required level and close it to the required level. Then already I have mentioned that hydrodynamic model like Brahma DRFF need to be applied for early warning with integrated information. Then when we are talking about good infrastructure, good forecasting, but most important part is infrastructure. Infrastructure should be improved to have a better forecast opportunity. There's number of rain gauge, number of stream monitoring station at the upstream. These are very interior area, but then even then and then latest technology like radar technology and all those should be clubbed together to have a more reliable and advanced forecast. This is another important aspect that we need to take. And emphasis should be given on downstream impact in general, because not only in case of dam failure, even when it is a hydropower dam, there is a diurnal variation at the downstream. There are technology, we have shown some technology, feasible technology, that downstream we always have a diurnal variation in the flood in the power production time. The flow is going very high, but in the time when we are accumulating flow in daytime, then the your downstream flow is almost nil. So how we can mitigate those diurnal variation, and also in the flood time when we are releasing heavy flow, how we can warning. So all these impact, the downstream impact should be given more emphasis in general. Now, stability of the upstream should be checked, and necessary management measures should be taken, or necessary measures should be taken to avoid landslide in the reservoir. There are cases, recently I visited Europe in one of the dam, that because of the landslide, the dam had to be abandoned long back. I mean, so this kind of, because removing those soil from the reservoir site is not that easy. These are all deep reservoir, and then it is where you will remove all those soil. So that become very much problematic. And life of the dam also goes down with that kind of sediment influx into the reservoir. So all these things need to be taken up in a very systematic way, in a very scientific way, and then I'm sure that we'll be able to reduce the disaster that we are facing now in future. I mean, we'll be able to reduce that to a great extent. So thank you very much. Thank you all. And I always acknowledge various doctoral students and various project staff that are working with me, and various funding agencies, those are supporting our work. So thank you very much. Thank you all.
Thank you, Professor Sharma. Excellent presentation it was. And before we go to our keynote speaker, Mr. Joshi, who has now joined the event, we have got two important announcements. That the first one is Mr. Niranjan Shaha, who is the director of GBS Energy Private Limited, is not well, throat problem, so he is unable to speak. So that's why he is not delivering his speech today. And second one, after we finish the keynote speaker, Mr. Balraj Joshi's speech, Mr. Saroj Kant Singh will cover as anchor for the rest of the event. Over to you, Saroj. And now I invite Mr. Balraj Joshi, who is ex-CMD of NHPC Limited, to start his talk. Over to you, Mr. Joshi. Mr. Joshi.
I think Mr. Joshi has left.
Just he was there.
He was there. He was there.
No, he is no more there. I think he has somehow gone out, and he will join very shortly. So that's why we go to our next speaker, Mr. Subroto Das. Can you start your presentation now, Mr. Das?
Yes.
Yeah. Please.
Good afternoon, all. Am I audible?
Yeah, you are totally audible, and you can continue.
My screen is visible.
Yes.
Yeah, now it's visible. Mr.
Yeah.
Das, you can continue.
Yeah, thank you so much. So thank you, Mr. Ghosh, for giving me the opportunity to speak in this forum of learned people across India, and especially then a good opportunity to connect with IIT Guwahati and all stalwarts from premier educational institution and who are into the field, industry. So I would specifically be trying to keep myself focused on the structure part. The and I'll start rather with a few questions. Actually, when there is any disaster or anything, so primarily it is because of course, rain, cloth, anything. But to take care of the mitigation, if our structure is safe, if our structure is safe, if our structure is stable, then this doesn't happen to the extent we have seen in the last couple of incidences, one in Teesta and another very recently in Telangana, the irrigation dam, of course. So yeah, so I asked with I share some questions which come to my mind or come to everyone's mind. And when did the failure process start? In any failure, we have seen the failure doesn't happen one day. So when this process start, what factors contributed to the disaster? How did things go wrong? Which assumptions proved to be incorrect? Were we able to identify the issues during the design? Did we adapt any shortcut? Did we integrate design processes, design monitoring in the project monitoring? Design monitoring, especially, this is a thing what I'd like to give emphasis on. Design monitoring means whatever I designed and during the construction, what is happening, the efficacy of the design. Did we check the efficacy of the software used for the design? Software having so many assumptions, so many factor, number. Does this number resemble with the real ground condition, especially with reference to the dam break analysis I'm telling, or any other seepage analysis, percolation, and piping analysis, mud flow, this kind of a thing. Did we make the software, or did somebody else make it for us? And their conditions, understanding by their words, we are doing things. Normally we do physical modeling to establish the efficacy. So did you do that? Of course, dam break analysis to be done physically, it might be very tough, but still then. Do you have record of construction methodology, planned versus designed? Because a hydropower project or irrigation project doesn't happen in a day. A dam construction take 4 to 5 years. During this, many things go. Maybe various kind of flood, maybe some landslide in between, maybe earthquake. What went wrong? Did we recheck the design and already constructed structure after major natural disaster? So these are some of the questions which come to my mind. And because this Sikkim disaster and the peer settlement in Telangana has shaken the construction industry from its base. It has shaken. It is unacceptable. It shall not happen. What went wrong? And if we don't discuss, if we camouflage everything every time, maybe we'll never be addressing the issue in the real sense. When safety is a concern, we must have then a robust system which shall involve every discipline, stakeholder in the processes. It shall not be in a sideway approach. Say, for example, the rock mechanics expert speaks only about rock. Yes, it is stable. The hydrology speaking in its own. The construction people have their limitation to the contract. So anyway, going to the next slide. So there are many stakeholders
which are involved. Number one is developer authority, government authority like CWC, CBIP, CWPRS, all this, lot many organizations, designers, construction agency, binded by contract, so many things make a mess of it. But issue is safety for all. Are we in the same platform? That's most important question. Are we in the same platform? Pain of one person being hurt by the other or not? The engineering problem is taken care at the site level or not? Or the site level has passed the information to the designer or not? Or ignored? Or passed the information to the authority or not? Of course, there are reasons not to, there are sufficient and more than enough reasons not to highlight many of the things because of the prime reason of involvement of the lending agencies, because these are not philanthropic work. But still then, when it comes to safety, we have to strike a balance. It is better not to have anything than to have an unsafe thing. So we must strike a balance. We shall not camouflage everything. So what actually needs to be monitored then? The DPR need to be monitored. The planning need to be monitored. The design, construction, as built, operation, maintenance, and repair, everything shall be in one place, which is, of course, not possible maybe by the manual system of the framework we are working with. We never look at DPR when it is in a construction stage. We never look at the initial design. We only go by the revised design. Is there a system to check the DPR, check the changes in the design made, check the construction changes being made, or during the as-built or any thing? Are they in one place? And if they're in one place, how are we addressing the issues? We are at all addressing or not? This is a very serious thing which goes on. And cutting short the time, solution is not that, it's not that. That year before, solution was not there, yes. It was manually. To check a design, to vet a design, it will require 3 or 4 or 5 days. We have to go to the paper, do calculation, everything, and see, and then come up with the things, collect data from the site manually, even going, letter, posts, photographs, only last 10, 15 years back. But today, we are perhaps not dependent with the old system of the working. We have enough technology with which we can really eliminate the extended time required for all this kind of analysis, number one. And number two, the human errors. And one most important thing is the biases. As per me, it shall not be. Or as per he is telling it is a risk, I'm not telling, I'm an expert. Who is an expert? I don't know. Really, I want to question myself. After having worked 30 years in construction and 3 years into consultancy, I still ask myself, who is an expert? I don't know. Because if I'm an expert, if the system, rather I am an expert is not important. Important is the system shall be smart and the system shall be like expert. And if we have the automated monitoring system, we are benefited. It can take care of everything with the factors like a real-time, it can have a real-time data. Real-time data does not mean only sensors of the dam built. Real-time data of the construction, real-time data of the contracts being signed, real-time data of the changes in the design which you are making, which normally in in the smart world today, we call it a BIM, building information modeling. The changes are incorporated in their digitized form and visual. It shall be linked to the schedule, and it shall give you automatic reminder. Based on the reminder, the predictive analysis shall happen to an extent, and after that, experts shall be told this is the prediction, and we improve upon immediately. And why not? We have an improved decision making, taking everything into a thing.
but manually it's not possible. Why manually it's not possible? So many coordination. Some people have retired. Some people have been transferred. Some company has been terminated. Another company has been brought. So many things. So if we take the help of a digitization and we develop an automated monitoring system right from DPR to production, operation and maintenance. So we can eradicate a lot many things. Now, how the system work? The system works on inputs for the data, then analyzing it by the software. Means we can develop a code. We develop code. We ask the problem statement, we develop a code. Tomorrow that code can be changed. Tomorrow that formula can be changed. Tomorrow CA give new guideline, okay, can be added. But do we have a system? That system has to be there, automated. Nobody shall work. Human being shall not work. Data shall only come, that's it. And data also, so many automation things are there. It can be mobile application, it can be your sensors, it can be photographs, it can be anything. Then integration with the government agencies and local communities. Then compliance monitoring. The compliance monitoring are happening. Is it happening as per the diagnosis of the automated system, automated monitoring? That has also to be checked. Otherwise, it will be simply a piece of letter. You comply with these things. It is risky. And he complied. He sent a letter, complied. So that's not really working. Questioning, sending a direction by a paper and then complied and reply is not working. If it is complied, there must be data. There must be data. Data shall tell it is complied or not. It shall be data based. It shall be software based. It shall be cloud computed. It shall not be night shift or day shift. It shall work 24 hours. It shall be cloud computed. Recently, we have designed such system for one of the real estate company, of course. Similar system has got enough room in the mitigation process, but the challenges are also there. And what are the challenges? Challenges is implementation pain, because we all are old. Even I am 56, 57 years old. If somebody tell me, we'll go for automation, some coding, then I'll tell, I don't understand this. I believe paper. Design has been done. It is only construction phase now. So we have to change. We have to relearn. The relearning scope is there. You have to really work on kind of a startup project, kind of a thing, and we shall be proactive in giving a solution to the people. But nobody will take pain. Important is, now, I'm old, so I'll not take pain in implementation of a new system and just scrapping the old system of 30, 40 year old, which I've been practicing and I'm an expert in that. So somebody shall go and tell and give them a ready-made thing. So IIT, it's a very good opportunity. They have access to everything. They can take things and go to the people. They have a thing. Tell the people that I'm giving you a system, go by it. And if you have anything, we can implement, we can add, do changes. But at least, even if you are on holiday, if you are on Sunday, things will be there. It shall not be like Sunday, night shift, no decision. Decision shall be data-driven, shall be programmed. The gate operation shall be programmed. So that kind of a system shall be there. Because night will be there, cold nights will be there, rainy nights will be there. Glove will be there only in rainy nights, might be. Or cloud burst will be there only in very bad weather. So one more challenge is resistant to change we are finding. And then data privacy and security, of course, is a concern. So to it, we have solved quite a lot. And we are giving the all access and all the things with the developer, with the customer. And those are all mobile authenticated. So the person who is operating it is the owner of the data. And it's the best security standard as just like Google or Amazon or anything, or Microsoft, because they are the platform we use. Now, what are the opportunities? One of the opportunity is we can have improved disaster management. We don't require any meeting for that. We don't require anything to come, call a meeting. People sit and think and brainstorming, and by the time we develop anything, and there was so many, we must have the program or algorithm or the program written down. We can have increased project efficiency too during construction phase, of course, I'm telling. So these are the thing we must eliminate the human error factor. It's a high time. It's a high time. Just now, Katua sir is my client actually. When I was working in Teesta Stage 5 powerhouse, so sir was there. So I know him. He doesn't know me. So he was just telling it was night. Yes, when you do manually, night and day matter. Yes, and the roadmap is first, if we take any project, we take this kind of a project, we take the assessment and plan, then we design the input, development, deployment, and data collection, data analysis and reporting, integration with authority with integration, and kind of a thing, and monitoring after the compliances. If it is complied, it will be appearing in the app. It has been complied. Nobody need to write. It has been complied. Believe me, sir. Believe me, it has been complied. Believe me, I have tried. No, it shall be based on data. But the system will be rigid. There will be no room for flexibility. Is one more challenge. I forgot to write. There will be no one to help than anyone. You have to do. You have to give this many sieve size sand. Then only it's there. Otherwise, it's not there. Or you can have some tolerances level also at the same time. Thank you. Within the short time, I could offer only this much. And if anyone have any questions, may please raise. Otherwise, I may proceed with my next slide.
Thank you. Thank you.
And to conclude, the implementation of an automated monitoring system offers a transformative opportunity to address the challenges and vulnerabilities of the hydroelectric sector in Teesta Riverine belt, ensuring safer, more sustainable and resilient projects for the future. Thank you for your patient hearing. And if any software or any kind of an application is to be developed, especially for the disaster management, my contact number is here. I'll share with the organizers too. And thank you for your attention. Thank you, sir.
Thank you, Mr. Subrata Das, for this enlightening session and lot of information and details we have received. Now we will invite our keynote speaker, Mr. Balraj Joshi.
If Mr. Joshi is not here, we'll wait for him for a couple of minutes. Okay?
Yeah, we'll wait.
You continue, and he is very shortly joining. Please wait for a couple of minutes for him. Okay?
I can suggest if there is some question answer from anybody that can be put forth. Sarojji, you can do like that.
Yes.
Speaker.
Any queries to any of the panelists or Mr. Subrata Das can be addressed here?
For me also, if any queries are there from anyone, then please feel free to have those because I have another meeting after this, so I'll have to leave.
To Mr. Katua,
yes,
I just want clarification. This Professor Mandal here.
Yes.
In your this thing, you had early warning system. That's definitely, I fully agree with that. And also you mentioned that some warning system was installed by ISRO, which apparently did not function to the expectation. What exactly happened? Any idea? I mean,
Yeah.
why it failed? Give
In
the warning.
September 16th or 17th, Sikkim government, disaster management, Sikkim government, and I think some
Right.
other year, they installed warning system in Lonak. That worked only for 2 days, then went out of order. There was from a European agency, they purchased it and installed it. That I came through the newspaper and other data based on. Again, in 2019, some early warning system was installed. That also worked for a few months, then it didn't work actually. And another thing that it should be integrated to downstream projects. If you
Yes.
see in Teesta River, there are 4 hydroelectric projects which have already been constructed. Apart from some another nine projects or 7 projects that have been constructed in tributaries. Only
Yes.
those projects which are in line with the Teesta project, like Teesta 3, Teesta 5, and in Bengal, TLDP 3, TLDP 4. See, NHPC projects are well connected with the projects downstream of Teesta 5. But the projects from private agencies, sometimes data, I was there for 3 years as head of the project of Teesta 5. To collect data from Teesta 3, it really becomes very, very difficult. People who are managing this operation, they don't directly give the data to us. Unless it is an emergency. You have to collect some data through their head office or somewhere else to get the data.
Yeah.
That system has to be reviewed so that, especially this type of frauds, immediately they should give the information that is really, really high immediate action is required. Though on that particular third night, district collectors, they were also after the people giving vacate the low-lying areas, other things. They did a lot there from Sikkim government side. But what I was telling, this reservoirs of Teesta 3 as well as Teesta 5, had it been emptied before the water reaches there, there was sufficient time. So much of water could have been stored there, and this effect of this flood could have been minimized.
That means this warning system, it is not only, Amitavada will say something, I'm just summarizing, it not only involves some so-called hardware warning system, but also a proper communication between the dams, between the downstream operations, communication should be there. Otherwise, things will not work. Anyway, Amitavada was raising a hand.
No, what I was telling, that huge experience and the data bank of the people who have worked post-independence in so many hydro projects is not there anywhere. Today, we are listening so many things from Mr. Khatua, who is a renowned man, but otherwise you will not listen. So there should be a systemized data bank, digitized data bank, so that people can access. I mean, it is going out. Even I am telling you, the information is not flowing. I work for 10 NHPC projects and at parallelly 2-3 projects, and I have seen even inside NHPC, information from one project does not go to another project. I have to connect through mobile that you check it out. This is the way. So there is no system. Actually, that system should be structured. Not that somebody calling me, I am talking, so people are listening. Why? Another thing, I'm telling you. Why I told under the umbrella of institution like IIT. It's a body, it's an umbrella where people can come. And then under the umbrella, when under the umbrella I'm speaking something, it has got some value. Otherwise, individual, there is no value. I will talk and give it will nothing. There are so many people, particularly, say NHPC is the best company, was the best company I have seen. And other company also, Nipcon, huge talent is there. This is one. Number two, that upgradation of technology, this is very much required, which has not happened, I must say. And this technology upgradation is possible after discussion, as Subodha told, which is very right, that in a modern system, should be incorporated. But that should happen discussion with the acclaimed industry experts that why it is required. And thirdly, my point is that human error which has taken place in Sikkim in different projects, as we are discussing, I was thinking that human error can always take place. I mean, how do you prevent that human error will not take place? Even he is maybe very intelligent, but in some time he may make mistake. So there should be a foolproof method. But how? That method, I feel, artificial intelligence, we can take the help so that some methodology can be adopted where even a human error can be taken care of. Yeah,
Sir, Mr. Sharma has a question.
Yeah.
Arup Kumar Sharma has raised his hand.
Yeah.
Yes, sir.
No, I do not have a question. I'm just when Professor Amitabh Ghosh was talking about, just one point into my mind, that from this forum, actually what we can do, Professor Mandal can take that lead probably.
Yes.
To collect all the information like that.
Yes.
Like in my presentation also, I have shown some of the
Yes.
technical work, as well
Yes.
as I also have experience of several such hydropower project, as well as other reservoir also. Those published work, at least those published work or any document related to this kind of dam can be collected, can be called for, and then we can share all those papers, and then that can be a library of that. If anyone asks, then they can know that this technology is available.
Absolutely.
This technology is available. So we need to
Very good
contact them.
suggestion.
We need to contact them. So like that. Similarly, from the industry side, NEPCO or NHPC or whatever dam building organization or dam operating organization, rather, they can make a documentation of all such, event, even in the construction period, whatever event has happened, whatever experience has gone into, that can be documented, and that also can be collected. Now there is a file or there is a total document, maybe with IIT or somewhere, and then we can always refer to that. This is the problem. This was the solution. This is the problem.
Correct.
This kind of thing is possible.
Correct. Absolutely correct.
And some
whatever I just interject, whatever experience we had in so many years.
Yes.
I think sometimes that I can write that mistakes and problems and solutions. What we did.
Yes.
And this, if somebody is available to somebody, so he can see that, okay, this person has in some time, he may not follow or may follow. It's up to him.
There can be further improvement always, but then at least he do not end up repeating the same thing, na? So that is
but at least you don't repeat that same. You don't
and I'm going one step further up. That artificial intelligence or GPT chat, whatever they call, there could be saying that this is the problem. Is there any reference? So he will give that this is the reference. Mr. Sharma did this. He will immediately get it.
Yes.
Why not? This is possible today's day.
Yes. Now it is
like
Mr. Das has a question. Yeah, Mr. Das.
Please.
Yes, sir. Thank you, Ghosh sir, for referring ChatGPT. Actually, ChatGPT is a LLM. It's a large language model. So they can, based on the words they give, possible combination of words come kind of a sentence. For technical reference, ChatGPT will be a risky thing. Recently, there was some issue in the US also. So he refers all wrong things also he refers. He connect by the words you ask. So doesn't refer to particular condition. It is not scientific. It's
Sir, no. It is scientific. I must say it is like a child now. It's like a 3-year-old child and it's learning. Maybe 10 years from now, you will see he's thinking faster than us.
Mr. Mandal, the point is what Mr. Ghosh is saying. He just mentioned ChatGPT, but actually application of AI, some application of artificial intelligence. Well, the people are here. That information put together and make the network of the artificial intelligence may be used, and by which maybe there can be some human negligence. time things happen because of human negligence, unintentional negligence. And
Right.
those avoid. So that is what.
Sir, just to add to Mr. Das's,
Yeah.
concern that, this chat GPT is a learning model. So just like humans learn, he's a learner. So, for example, I have a friend in Hyderabad, I gave his name, Rajesh Kandla Gutta. Who is Rajesh Kandla Gutta? It could not search. He says, I don't know. But if I give, who is Mr. Amitabh Ghosh, he's immediately go to GBS's page or LinkedIn profile and give me the exact, Amitabh Ghosh, or he may say, these are the Amitabh Ghoshes. He will give whatever is in the net. If he has seen, he will extract from there. So, in technical side also, slowly they will train him. And already it is happening.
Yeah. So important is whatever technology we have today. Say, for example, when we tell a person, if this is the condition, you do this. If this is the scenario, if this is the flood flow, you open this many percentage of the gate. If this is the settlement in the dam foundation, you stop work and do grouting and observe the settlement for further this many days. If these instructions are already available with the experts in the books, in the journal, in the guideline, then these all instructions can be given in the code. And as soon as it reads some such similar kind of a trigger, it informs immediately our mobile. This technology I was talking. And we are giving these solutions to small companies. If his person is absent today, then immediately the next hierarchy person will be allocated with the job. So this is what is called automation.
Escalating
So,
the issue.
now, I will just add one thing. See, today there are two groups. One group like us who knows the work but do not know the digital technology. Okay. We do not know artificial intelligence or latest technology. We do not know. And there is other group who knows the digital technology. Maybe they do not know the work itself. And combination of these two groups are very much required. I have done some project, process control automation. With Siemens Germany, we did the work in Durgapur Steel Plant. There, we found the people who are doing the automation, they do not know the process.
Yes.
And we know the process, but we do not know the automation.
Yes.
And we sat together and then we made a solution. And the automation fellow told us, we can also do this. Why don't you do this? When discussion, it comes. You want this, but I can also give you this. This sort of discussion is very much required. Otherwise, nothing will come up.
Nothing will
See,
come
there
up.
are two groups going parallelly. We are experts so many years thick, but we do not like, human error. I feel that there must be some process involved where we can take care even some portion of human error. Otherwise,
Yes. Possible.
and those, because why I'm telling, because we have all spent our life in hilly areas, and I have seen in those areas, it is very difficult to keep yourself cool and do everything work properly. Mr. Khatwa knows, I'll tell you one example. One finance team went and they tried to find out whether everything goes wrong. So then he found that everything is right. Then other fellow said there's something wrong. How can they make right in this situation? So when everything, it is very risky. And risk is the part and parcel of hydro project that one has to recognize. First, you cannot say it is very no risk. But how to mitigate risk, that's our job. This thing. Yes, Mr. Khatwa.
Yeah, I was just telling this Subhadri who raised a point, whether there is certain guidelines for operating the hydro projects or not. Yes, it is there.
There.
It is from basin to basin varies.
Yes.
Project to project vary. Even same basin, 3-4 projects are there. It is project to project, it also vary.
Right, sir.
Teesta 5, and when I was head of the project, their proper guidelines are there. Normally, in monsoon season, the reservoir level should be kept at MDDL level, minimum drawdown level. where power can be generated as well as reservoir is at a lower level. In that case, any flood coming suddenly, by the time to open the gate, I think Amita Ghosh sir can tell rightly, all the 4 gates to open it, it may take 20-30 minutes. Within that time, the flood will not overtop the river, that dam.
Dam.
That's why this kept at a lower level. But in particular, this case, on 3rd of October, what we have learned from others, that reservoir level of both the projects, Teesta 3 as well as Teesta 5, were at a very high level. Once it is at high level, it cannot absorb more water.
Yes.
There is no time to absorb the more water and takes time to open the gates. That's why some error is there somewhere to open the gates as well as keeping the reservoir level at a lower level, which is
Maintaining it.
the
Maintaining it.
Mr. Sharma has a question.
And that
Yeah,
time it was
sure.
raining also heavily.
Yeah, I want to add to this. Basically, what is said that all reservoir has a operation rule, okay, rule curve kind of things or various
Yes,
operation
yes.
strategy. But point is that operation strategy is generally based on whatever inflow level or whatever stories in the reservoir. So based on all, I mean, upstream of the reservoir, whatever information we have. But considering the downstream situation, we need to provide, I mean, any operation strategy. That's what in my presentation I was suggesting, that we can have more, I mean, dynamically operating rule, so that considering all this information, we can generate the operating rule that, okay, reservoir has this level, but at downstream you do not have flow at this moment, so you can release more. But downstream you also have flow, and you cannot make advanced release because it will cause downstream flooding. So that kind of integrated operation rule through automation, that's what we are working with NEPCO also, that through sensor-based information, how we can give that kind of system. Okay, so that need to be tested. Thank you.
Sir, can we invite our next speaker if Mr. Joshi is taking some time?
Just a minute. If,
Yeah, Mr. Das.
Dr. Sharma, if in future, if any kind of automation support is required,
Yes.
Please feel free to tell us, sir. We are doing it, and for IIT Guwahati pilot project, we'll do it, sir, and we'll not charge anything.
Okay.
No,
Thank
Mr.
you.
Das.
Thank you for that.
No.
Good
Yes.
offer.
So you please send your detailed mail ID and also that.
Yeah, it's already there. Actually, I'll share with Mr. Ghosh. It will be there.
Okay.
Okay, Mr. Das.
Yeah.
Mr. Das. Actually, this is the starting point of our initiative. You know, we have to go a long way on this. You know, it's a starting point we have assembled, and we are interacting with all this stuff. But we are of the same opinion that something should be done.
Yes.
This is the first point. Otherwise, you know, the high-level committee will come. I know what will happen. They will give a big recommendation. Something will be implemented, something not. And after few months, you will see the same situation. So what we have done then? I mean, as a senior citizen, I'm 76 years old. I feel that I have a passion for hydro work. I mean, without passion, you cannot do work, you know, this time. And I hats off to the people who are working at site, at remote places, years after years. I mean, it's a very, very difficult work. People have to understand, you know, in what situation people are working. You know, somebody told me they are like defense people without arms and ammunition.
Yes.
Yes.
All hydropower engineers tell that only.
That only.
Yes.
Okay, so thank you very much. I will be leaving now because I have a meeting from 4:30.
Dr. Sharma,
nice meeting
thank
all
you
of
very
you.
Much.
Thank you very much.
Thank you.
Okay.
Thank you very much.
Okay.
Professor. Sure.
Saroj.
Yes, sir. Mr. Tapan Kumar Dhar has been waiting for some time. He's Indian Registrar of Shipping. I think we can hear his presentation.
Yes.
Mr. Dhar, you can start.
Good afternoon, everybody.
Good afternoon.
First of all, I beg the opportunity to say everybody and regret that actually I was very sick, and recently, just 2 3 days back, I have rejoined my business. So I got this information very late, and particularly in this natural disaster field and hydroelectric IRS is industrial also. We are doing in so many industrial projects, uh, like you might be knowing in Guwahati, we have constructed, there is constructed at 5 kilometer long rail-cum road bridge, where we have done the project monitoring system, uh, project monitoring of the total whole project. There are a lot of welding and inspections were carried out. So sorry to say I couldn't make any presentation, but in brief, I can say uh, in particularly in fabrication or any other, not in the form of say natural disaster or any field of construction work, whether it is fabrication work or it is the civil construction work, there should be a systematic checking system at every step from the very starting point of the DPR, where the DPR is being made properly, that should be checked out. Feasibility of the DPR, and then the execution. Before execution, if I concentrate on the fabrication and all, so we have experienced a very good uh, knowledge in that Bogeyville project, where the whole construction, design, construction, welding, everything was done as per the European codes, Euro code. And we have done so many projects as per European codes, IS codes, and American codes. Well, as far as my knowledge goes, so I can say that the European code is very stringent, it's very clear, and it's and very um, self-defensive also. There are checkpoints at every time from the start of the design parameter of the welding, how to select the welding welder, welding materials, the material, everything. And that is the thing. So whenever we are going for a construction, we have to see for what in what climate, in what condition we are doing, what is the major climatic conditions, what is the other design parameters, everything, what are the materials being used, and based on the all the welding designs should be done accordingly, the welding procedure specification, following which the all the weldings will be carried out are being freezed. As per that, the welding procedures are being made, that is being tested. It is being established. If it is established, then the welding can be started, and the subsequent welders we are doing, they are also has to undergo a test, very vigorous test procedure and very vigorous under supervision. These are to be, and also the welding has to be tested with various destructive and non-destructive testings. So, as my suggestion for NHPC jobs also, there are so many weldings are involved. So we can follow, we can go. I don't know because I don't have any personal experience on hydroelectric project, but my suggestion is that we can go as per the European codes, which are very clear and very restrictive and pinpointed. So what is to be done, how it is to be done, what are the defects can arrive, how you to solution to give the solution, even them to the, how to test, inspect the buildings. So that is one thing, and another thing is that the personnel, and supervision. So the personnel means the workmen or welders who are doing the welding. There should be a very strong vigilance over there, because in India I have experienced that the welders, they are good, very good welders, everything, but there are a tendency for us that we will do as far as, say, if it is 8 hours job, we will finish it in 4 hours, and 4 hours we will take rest. So that is the majority. So that vigilance, whatever work they are doing, maybe they are doing 80%. So 80% should be done very accurately, very cautiously, and vigilance should be there. Checking should be there that they are doing very well, very well, and at every stage the inspection should be done. So that is the thing. And another point is that the final inspection authorities or all, they should be also very careful that all these activities, starting from the design and the finishing of the job, that every stage has been covered, everything is there, and regular quality monitoring and should be there, or quality audit should be there. And accordingly, that report should be sent to the respective authority for their knowledge that these things are going on, and that should be overcome. If any deficiencies, any discrepancies are coming, that should be overcome. That should be taken care for necessary rectification from their end. So that's all. And so once again, I am great myself due to my ill health. I couldn't present any presentation in this forum, a very big forum. That is a very good opportunity for me. Still, I am hearing from the stalwarts of this industry as well as IIT also. That is a very good opportunity for me. I am very thankful to IIT Guwahati for inviting me and allowing me to speak on this forum. Thank you very much.
Thank you, Mr. Dhar, for your experiences in the aspects of quality and safety in shipping and in the welding side, which is very crucial and very important, especially in the shipping line of business, and also in hydroelectric, whether I think Mr. Ghosh can inform about the penstock welding, how critical it is, and why it is very important. I think Mr. Das also touched upon this area where the DPR and all the stages should be covered, for capturing these kind of risks. Mr. Ghosh, I think can share
I
further.
would like to interject. Thank you very much, Mr. Dhar, for your speech. I would like to talk about the importance of welding technology or weldments in hydro work, particularly in the area of penstock. Penstock welding is very critical, very difficult, and most of the welding has to be done, a lot of work to be done at site. The site welding is done, material is very where material 517 grade F, 537 class 1, and the welding is also very high quality, and the diameter could be 3 meters, 4 meters, 6, 8 meters. So what happens that we have seen in a lot of projects, after the welding is done and the penstock is ready, and we are trying out with the hydro test, that this is heavy leakage bursting. I mean, this has happened for quite a few hydro projects, like, even Teesta 3, which was the dam has breached in Sikkim, and also Kamen, then Seva 1, and other projects. Malana, few projects it has happened. One of the reasons is that the quality is not checked at all during erection commissioning or during. And also, what we have, Mr. Dr. Mondal and myself went to Kamen, and we have seen the defect could be as high as 30-40%, level. And also, another thing I must say, that modern technology of welding, auto welding, is never used. See, big diameter, 3-4 welders start at a time, and particularly inside tunnel, it is so difficult. And good welders do it, and finally the defects are not rectified. So this is possible to be eliminated if we use latest technology, welding methods, and also we are saying that artificial intelligence, if possible. This is a must. Otherwise, all the projects will have a very doubt whether the welding has been done correctly. As I was telling Dr. Mondal, he was telling this never happens in the shipping industry. When a ship is launched, we cannot expect that there is a leakage in the welding and the water is going inside the ship. So this point I just want to repeat this. Mr. Dr. Mondal, you want to add?
No, what you have said is correct. I mean, because as I have mentioned in my when I just introduced the workshop, that a stringent monitoring policy is needed. On pen and paper, it is there for hydro projects. But what we have seen,
Mr. Dhar, can you mute yourself? Some background noise is coming. Mr. Tapandar, kindly mute.
yeah.
Yes, sir.
So, what happens in shipbuilding? It's rightly said that as I put the ship in water, it will remain in water, but you cannot expect any leakage there. Same thing, a penstock, when it will become operational, always there will be water inside, and I should not expect any leakage there. So in the commissioning stage, right there, it starts leaking. The problem is in shipbuilding, the continuous involvement of this monitoring agency, right from the design stage to material procurement, material testing, to the erection. At the erection time also, they are continuously monitored. This should be implemented. Here on pen and paper, it is there, but not in true spirit implemented. So we have seen disastrous things happen. The kind of very bad welding. And another point, what Mr. Ghosh has pointed out, that we should be now thinking of implementing some automation in the welding, which is not very difficult, which can be implemented for penstock welding. Then what happens inside that tunnel, inside the penstock, even a good welder, he can't work for a long time. You get fatigued and you are in a hurry to deposit metal to maximize your output, right? And you do bad welding. Not to talk about doing, wrong things, putting electrodes and just deposit metal on top of that. And anyway, so that is very important. So there, we felt that agencies like IRS who are very much qualified and their job is this, they can be involved, right, to do the monitoring, because they have their industrial wing where till now they have not been associated with any hydro projects. It can be done. So we can ensure that the erection stage things are going in the right direction and proper quality check will be there. So that is it. Thank you.
Thank you.
Thank you, sir. I think this session is very much pertinent today when there has been an earthquake in Nepal, and a number of deaths have already happened. The news channels are all reporting it since morning. And although it's not hydro, we had lessons from Teesta. And if, the disaster management learnings could be, there, I think such, incidents can be contained. In fact, the state of Orissa and, certain states which continuously come across such calamities have very well trained teams, just like the country of Japan, and they contain. However, states which do not have these kind of calamities sometimes are unable to contain, and the small crisis becomes a big disaster. So I think this session has, provided, you can say, a starting point where we can collate data and create this kind of a knowledge bank, as Mr. Ghosh had mentioned. And I think with that, if there are no other speakers, Mr. Ghosh.
Hello, can you hear me?
Yes, sir.
Yeah. No, I think I just discussed with Dr. Mandal. We had a very nice session, and this is the starting point of, I would say, industry IIT industry initiative to take it forward towards mission hydro safety. And then we will detail out plan on this, how to work with in a structured way. And we wanted to have a session like this, workshop we call it. And I would like to, thank everybody, whoever has participated. And I only missed Mr. Balraj Joshi, probably because he has already a meeting in NCLT meeting in Chennai. So he was trying to come out, but I think he could not make it. He said there's nothing. So anyway, but we had a nice session. Mr. Dr. Mondal, Nishit, you would like to add?
Yes, today's discussions, though not all the speakers they could join us, but whoever has joined definitely contributed very positively, right? And as I mentioned in the beginning, that it should not end with this conducting this workshop. No, our focus is just to have to get the views of all concerned people, and then take it forward. And how to take it what to do, that has also been outlined by Mr. Ghosh. And what Professor Sharma has mentioned, that we'll try to coordinate with IIT Guwahati, because what happens, IIT gives a very big umbrella. IIT's umbrella is very big.
Yes.
So we'll have to utilize that, capitalize on that. So we'll team up with IIT Guwahati people and with the industry, other experts, and the objective is to make IIT TIH, Technology Innovation Hub of IIT Guwahati, as a nodal body, nodal agency, who will have to impress upon the local government or the administration that there should be a nodal agency who will look after these issues, everything of hydroelectric sector. Like I said, in shipbuilding, we have the already established agencies like classification societies. Since it is not here, so the nodal agency, they will take help of this IRS people who are expert in welding and material inspection, etc. As well as we'll have people to check on the design aspects. We will have people who can suggest automation in welding and so on and so forth, so that we can possibly contribute, and we just do not go get away saying that, well, it was a natural calamity and disaster can happen. Not that way. And not to talk about, no calamity, but still disaster happens in
Yes.
hydro, this projects we have seen. So it should be now, it's high time. What my experience goes is, what I have seen, that there has not been any innovation in this. I mean, it is continuing traditional, very, very traditional industry, very traditional. We have to put in various technologies are now available. We have to put in that. And also that early warning system and all that. That's what I asked Mr. Katua, that what happened? The ISRO install, he said it worked for 3 months and then stopped. These are not, should not be such things happening in this 21st century. So, well, a lot of things are there possible. We'll certainly will be able to take it forward with help of all these people. Okay, thank you. So that
Thank you. So we thank you very much, and thanks everybody. Maybe we'll have a next meeting in offline, online, maybe in Guwahati or maybe in Calcutta, or online.
Yeah.
Okay.
Okay. Okay.
Thank you very much. Thank you, Swaraj.
Thank you, sir.
Thank you, sir. Thank you.
Thank you. Thank you so much.